Hello everyone, welcome to second video of CM1 by SMO. Myself Ravi, and we will continue studying here the first chapter that we had been studying in the previous video, which is theory of interest rates. So in the previous video we saw what was simple interest and compound interest, and here in this video we will see what is called as simple discount and compound discount. So let us start with the chapter. So we saw in the previous video how to accumulate. Accumulate means if you invest some amount right now, how do you find the amount that you have in your account or investment fund after a certain number of years, after it has earned some rate of returns that we call as interest. Now here we have a new challenge in this video, and the challenge name is to find the present value. Finding present value basically means if we need some amount sometimes in future. Let's say that I'm planning to invest some amount right now so that I have 1 lakh rupees in future. So if I want to have 1 lakh rupees in future, how much money should I invest right now is the question. That is what is called as the present value of the future amount or the future cash flow. So here we'll be dealing with calculating present values. So there are different ways to understand the present values, and there are different applications of the present values. We'll first understand how to find what is the concept of discount rate that we use to find present values, and then we will also understand how to find present values using interest rates, and then also we will understand how discount rates and interest rates are related to each other. So let us start with understanding first the discount rates. So taking a very simple example, first of all, finding present value is also called as discounting. When I say finding present value, discount, it is another same thing. So at time 1, let's say that you have to pay someone say 100 rupees. You had to pay 100 rupees to someone at time 1, and let's say for example that person wants you to pay that amount right now. So that person is asking you or requesting you to pay that amount right now in advance in 1 year in advance. So the question is now, if you agree to pay, taking into account the finance or the commercial viability behind paying the money in advance, how much amount should we agree to pay? Should we pay full 100 rupees right now? Should we pay something more than 100 rupees right now, or should we pay something less than 100 rupees right now? Now this question arises because the time value of money changes. The 100 rupees after 1 year is not worth 100 rupees right now. It is different. So we have to find out how much money should we pay right now, and the obvious answer should be you should pay something less, because the 100 rupees after 1 year, the purchasing power of that 100 rupees is definitely very less as compared to 100 rupees right now. So maybe we could agree to pay 95 rupees right now instead of 100 rupees in future. So let's say that we agree to pay 95 rupees to settle the transaction. Instead of 100 rupees, 1 year in advance you pay 95 rupees. So here in this transaction you got 5% discount. So we can use this, I can use the statement, I can say the statement 95 is the present value of rupees 100 due at time 1. 95 is the present value of rupees 100 due at time 1, and this present value is calculated using 5% discount. Now since this I have assumed to be 1 year, I can say 5% per annum discount. So this is what the discount rate is. How much less, how much percentage less of the original amount you have to pay right now if you want to pay in advance. One of the simple way to understand it. So let's understand types of discount rates. Discount rates are of various types. We'll study 2 types here: simple discount and compound discount. Now the simple discount and the compound discount concept works similar to the concept of the simple interest and compound interest. So this was for 1 year. Let's say assume the same thing for 3 years. Rupees 100 is due at time 3. So you have to pay someone 100 rupees 3 years from today. And if you wanted to pay in advance, the person agrees to give you 10% per annum discount. So we can write D is equal to 0.1. D is used to denote the discount rate. Now let's check how it works. So if it is simple discount, first of all, in the first case, 100 rupees 1 year before will become 90 rupees. If you discount 100 rupees for 1 year by 10%, it becomes 90 rupees. 10% of 100 rupees will be given as discount. Take it 2 years behind, it becomes 80 rupees. So 10% of the original amount, 100 rupees, should be discounted every time the discount is given. And for the third year, now again it should be 10% of this, so it becomes 70. So you're getting same percentage of the final value as discount every time the discount is being given for every year. Now let's think of compound discount 100. So for the first year again discount remains same. That's happened well for the simple interest and compound interest case also. So for the first year you get 10% discount. Now for the second year you get 10% discount of this 90 rupees instead of this 100 rupees. That is the only change. So 10% of 90 rupees makes it 9 rupees. So your discounted value should be 81. And take 1 year behind more, so you get discount of 8.1 rupees. So after a discount of 8.1 rupees, this should become 72.9. So present value of 100 rupees using compounded discount of 10% is 72.9 and simple discount 10% is 70. So you get more discount in case of simple discount as compared to compound discount. The case used to be exactly opposite for the interest, but that is how it works. In compound interest you get more interest, so in compound discount you get less discount. That's how it works. And in almost every major organized financial sector, be it banks or be it insurance company, be it pension funds, be it any other organized financial sector, compound discount is what is used. Usually only for a transaction of very small time period, let's say 3 months, 6 months, 9 months, a simple rate of discount may be used sometimes. So I can, having understood this transaction, how it mathematically works, I can write the simple definition of simple discount in my own way. Simple discount is given on final value each year, and here discount is given on discounted value of previous year. I can write two simple, very informal definitions of the two just for your understanding, to keep to remember how it works in practice. So definitions of simple discount, compound discount you have just written. Let's also derive a formal formula to find the discounted value or the present value when the time period is not as small that you can calculate it manually. So when you want to calculate the present values for a long time period, we need ready-made formulas for that. Let's see how it works. So for simple discount and compound discount, let us assume we have P rupees at the start, that is at time n. Here we have P rupees in both the cases. Now we want to discount for 1 year behind. So you want to come to time n minus 1, you want to come 1 year back behind. So P rupees will get subtracted by a certain discount amount. So let's say the discount amount is denoted as D. Let's denote it by D. So P is the original amount. You subtract certain percentage, that is of the original amount, P into D. D being the certain percentage of discount, whatever percentage of discount that is being provided. And the story is exactly same for compound discount as well in this, at least for the 1 year discount case. This is what my formula that comes out to be, P into 1 minus D in both the cases. Now for the second year, when you discount for 2 years, you come even 1 more year behind, your discount amount remains exactly same for the simple discount case. So initial whatever the amount was applicable, now twice of that amount becomes the discount amount for the second year. So I can write my formula as P into 1 minus 2D, and here I can say my discounted value is P1 minus D, the original amount, minus P into 1 minus D multiplied by D. This formula comes from the same logic that we use in compound interest. This is the amount already due, and you'll get discount on this amount now instead of the original amount. So this amount into D becomes a discount value. So you take P1 minus D common in both these things, and you get 1 minus D inside the bracket, which makes it P1 minus D square. In the similar way, if you keep on solving, if you come down to time 0, that is discounting for full n years. So if you discount for 1 year, it is 1D. If you discount for 2 years, it is 2D. So if you discount for n years, it should be P into 1 minus ND, and here it should be P into 1 minus d raised to n. These are your formulas for finding discounted value or the present value using simple discount or compound discount. The formulas are pretty easy to remember. If you remember the simple interest case, simple interest was certain percentage addition on the initial amount. Here it is certain percentage subtraction. So just your plus I got replaced by minus d, and you get a formula for simple discount from the simple interest. So you can relate it with the simple interest. The same happens with the compound discount case. If you remember, it was p into 1 plus I raised to n for compound interest, and here it is 1 minus d raised to n. There also it was adding certain percentage every time. Here you are reducing certain percentage every time. So your plus I got replaced by minus d, and that is the only difference here that you can see. And the formulas are quite relatable, easy to remember, and not very difficult to understand. So having written this, let us solve some questions on this further. So we right now saw how to find present values using simple discount and compound discount. I'll write the formula here once. So we saw that present value is equal to future value into 1 minus nd. Now here when I write future value, I'm just referring to the amount that was due after a certain number of years. So in our case, 100 rupees in the previous example was the future value. So whenever in this video when I discuss, whenever I say present value, it means the amount that you should pay equivalently right now, in place of the amount that was supposed to be paid after a certain number of years. And the amount after a certain number of years that was supposed to be paid can be referred to as future value. So this was for simple discount, and for compound discount we can say present value is future value into 1 minus d the whole raised 4 to the power n for compound discount. So we got two formulas for finding present values using discount rates. How much percentage discount is being awarded for each year. This term, or I would rather call it factor, this factor and this factor are called as discount factors. Discount factors for simple discount is 1 minus nd, and for compound discount is 1 minus d whole raised to n. So discount factor basically gives you information of how much times of the initial amount should be paid right now as its equivalent amount or its present value. What is the present value of the future amount? So if present value of 100 is 70 rupees, we say that discount factor is 0.7. So this is how we understood accumulation factor as well in the previous video. So relatable, if something you're multiplying to the present value into accumulation factor gives the future value, and future value into discount factor should give you present value. So what needs to be multiplied to find the present value is something called as discount factor, and what needs to be multiplied to find the future value is called as the accumulation factor. Understanding the two factors in very simple terms. So we can now solve some questions on this. For example, let's say rupees 500 is due at time 7 and discount rate is 10% per annum. Simple. Find its present value. We need to find the present value of rupees 500 that is due at time 7 using 10% simple rate of discount. So the answer should be present value is equal to 500 into 1 minus n. N is 7 into d. D is 0.1. So 500 1 minus 0.7, that is 500 into 0.3, which gives me my answer as 150. So 150 is the present value of rupees 500 that is due after 7 years using the discount rate of 10% per annum. So even in exams, if you write this step and derive this step, it is perfectly fine. The rest of the things can be done by the calculators. You don't need to solve things manually because the examiners in examination are allowed to use the calculators to make most efficient use of it and save as much time as you can using the calculators. Now let's say for example, we have rupees 600 due at time 15. Discount rate is, let's say, 6% per annum compound. Now even if I don't write compound and if I don't write simple, always assume it to be compound. The question need not always specify as compound. So your present value should be 600 into 1 minus 0.06 the whole raised to 15. let us see what is the answer in the calculator. So answer that I'm getting is 237.1750793. This is my answer using the compound discount case. Now let's say for the same question, if I say my discount rate is 8% per annum for 10 years and 6% per annum thereafter. There should not be very much changes in the answers. It should be simply be 600 1 minus 0.08 raised to 10 into 1 minus 0.06 whole raised to 5. Just multiply discount factors. So create one discount factor for 10 years, another for 5 years. So total this is discount factor for 15 years, which was actually the timing of the payment. So just multiply this and you will get your answers. Let's see what is the answer. 1 minus 0.08 the whole raised to 10 and 1 minus 0.06 the whole raised to 5. My answer comes out to be 191.279663. Of course, this is smaller than the previous one because here I discounted only using 6%. And now I have used a higher discount rate 8%. So my answer becomes follow. I tend to get more discount if I use the higher discount rate. So that is how it works. It's pretty easy and not very difficult to understand, I believe. So make sure that you practice questions like this as much as you can. We have provided you with the question bank to practice yourself, to be thorough with these questions. So solve these questions yourself and get back to me for doubts. Let us right now take one more example. Let's say in the same question I'll continue. If I have a new discount rate given, let's say 3% per quarter. 600 is due at time 15 and the interest discount rate is 3% per quarter. So what I need to do is simply 1 minus d is 0.03 and I need to find how many quarters do I have in 15 years. So I have 60 quarters, so I'll do raised to 60 and I'll get my answer 600 into 0.97 the whole raised to 60 and the answer comes out to be 96.484. So that's how you find the discount rates for the time period of discount which is less than once in a year, So here the discount rate was per quarter, so you got quarterly discount rate, and then you replace n, that is 15 years, with the number of quarters in those 15 years. So just be consistent with the discount rate and the time period of the discount rate in the n. So the same thing we did for compound interest, simple interest, and the same thing we're doing over here. There is something new that is being introduced here. So just your discount rate and the number of and the n, the time unit, should be consistent with each other. So that is it for the discount rate. It's a very simple topic. Let us move on to the next topic now. So the next topic that we need to discuss is the relationship of the discount factors and the accumulation factors. And we'll see how interest rates can be used to discount and how discount rates can be used to accumulate. Right now we saw interest rates and then we saw its accumulation factor, then we introduced discount rate, then we saw its discount factors. Now let us see, we had written some amount which is due at time 0, let's say P, and we want to find amount at time N. We did P into 1 plus Ni. Now it should be very clear or should not be very confusing for you if I tell you that this P is my present value and this is my future value. These both are the equivalent amounts. The P rupees right now is equivalent to P into 1 plus Ni after a certain number of years. So this both comes through the same transaction. It's just that P is earning interest because the payments are getting, the money is getting invested for a certain number of years. So P is the amount right now, so I can refer it to as present value, and P1 plus Ni can be referred to as future value. So I can write present value into 1 plus Ni gives you future value. So can I find present value when it is not given but the future value is given? So I can simply take future value into 1 plus Ni. I can take this 1 plus Ni term over here, its inverse function, and I can get the present value. So if future value is known, N is known, interest rate is known, the present value can be found out. So you can use the interest rate, simple interest rate, to find present value also. And we saw in the just a few minutes back that future value into discount factor always gives you present value. So this is my discount factor, and present value into accumulation factor gives you future value. So this is my accumulation factor. So accumulation factor, which we denote as A0 comma n, can be written here as 1 plus ni. A0 comma n can also be referred to as an if it is starting from 0, and if it is not starting from 0, you have to write whatever the number it is, but if it is by default 0, you can always write an just. Discount factor can be denoted as Vn. V and n in the bracket. I did not write it previously, you can note it right now. That discount factor has got this notation. This is V is for value and n is for the number of years for which you need to discount. This is 1 plus ni raised to minus 1. From here I took the information. So for simple interest, I have accumulation factor, I have discount factor. I can clearly see that discount factor is inverse of the accumulation factor, or I can say accumulation factor is inverse of the discount factor. Now this is the case for simple interest. Let me understand for simple discount. We wrote present value equal to future value into 1 minus nd. I can well write that present value into 1 minus nd raised to minus 1 should give me future value. So my accumulation factor for simple discount is 1 minus nd raised to minus 1, and discount factor we had already introduced to be 1 minus nd, that can be verified from here. So again, for discount rate, I got to find out what is my accumulation factor, what is my discount factor. So from what is written on the board, we can understand that interest rates can be used to discount as well as accumulate. So interest rate is not only for accumulation, it is for both of them. Similarly, discount rate can be used to discount as well as accumulate. Discount rates are not just for discounting, it can be used to accumulate as well. Similarly, for compound interest, we wrote present value into 1 plus I raised to n gives the future value. I can also write that present value is equal to future value into 1 plus I raised to minus n. So again, I got my accumulation factor as 1 plus I raised to n, and discount factor is 1 plus I raised to minus n. So again, you can find present values using compound interest rate, also accumulated values using compound interest rate. Accumulation is very obvious, but we understood that we can find present values also using the compound interest rate. For compound discount, we had written that present value is equal to future value into 1 minus d to the power n. I can also write future value is equal to present value into 1 minus d raised to minus n. So again, my accumulation factor is 1 minus d to the power minus n, and discount factor is 1 minus d to the power n. So now, having seen all the four cases, we can say that any kind of interest rate or any kind of discount rate can be used either to accumulate or to discount. Both things are definitely possible. And one thing that we can see for sure, that accumulation factor is always the inverse of the discount factor. So if you know one of them, you can find the other. So for example, if I say accumulation factor for 5 years is to find present value of rupees 1000 due at time 5. So if I know that if I invest some money for 5 years, my money usually tends to get doubled. So if I invest 100 rupees, I'll get 200 rupees back. If I invest 1000 rupees, I'll get 2000 rupees back after 5 years. So I know the accumulation factor. And the question says that 1000 rupees is due at time 5, we need to find its present value. So present value is 1000 into 1 upon, or you can first write 1000 into V5, which is discount factor. You need to discount 1000 rupees for 5 years. Then you can write this as 1000 into 1 upon A5, since neither the discount rate nor the interest rate, nothing is given. So we need to use the accumulation factor that is given, which is 1000 into 1 by 2, which is 500. So present value of 1000 rupees due at time 5 using accumulation factor I got as 500 rupees. So this is how you find the present values using accumulation factors, or you can similarly find accumulated values using discount factors. So discount factors and accumulation factors are very important. We'll be using these terms very frequently in many of the questions and many of the topics further. So keep a note of this. Right now we are keeping it to this much information only, but we will build on these concepts later on as we develop more concepts about the subject. So let's start with the next topic. The very important topic now to understand here is principle of consistency. So this is a small theoretical kind of a topic, but which has got very intense and very important mathematical applications or implications. So this principle of consistency, which we're going to discuss right now, is going to be the base of all the equations or all the formulas that we create or form or find out in the further chapters and the further topics in this chapter also. So the topic is principle of consistency. So I'll dictate, you can write the details or the description of the principle. So you can make a note. Principle of consistency states that no two investors can earn different rate of return based on the action taken by them. No two investors can earn different rate of returns based on the action taken by them. So this means that if there are two investors in the market and who are investing in the same product for the same length of time, taking the same risk, the returns that they earn should not depend based on anything, based on the amount invested, based on the frequency of disinvestment and investment, or anything that they want to do. There is no way they can influence the returns by their own actions. So let's understand this practically with some few examples. Let's say Mr. X goes to a bank and he makes a deposit of some amount, let's say 100 rupees for 5 years, and he has got 150 rupees by the end of the 5th year. He put his money in the fixed deposit in the bank. Now second person Y, let's say, he invests 100 rupees here, then he disinvests at time 2, so he'll get some let's say amount A back, then he reinvests that amount in the bank for let's say till time 4, then he gets some B rupees back, and then he reinvests the amount, and then he has got some amount at time 5. Here he should still have 150 rupees only. Now it happens that the rate of interest keeps on changing with time. So by the time the person is at time 2, let's say he invested for 10% per annum, so he got 10% per annum for 2 years, and then the rate of interest may change. But it happens that practically also this happens very frequently. In some cases this may not hold true, but in most of the cases I would say this holds true to a great extent, that no matter how you invest for 2 years, 2 years and then 1 year, and then or you invest for 3 years and then 2 years, or you invest for 4 years and then 1 year, the amount that Mr. Y will also have in his account will be 150 rupees only, or theoretically at least it should be 150 rupees only. It should not be different. The rate of return that the persons are earning, that both of them are earning, should not depend on how they have invested. If you have invested for longer term at one time, or if invested in shorter durations, your returns should not change. If at all there is a scope of change, that scope, the changes should be nullified by the taxation or the transaction cost that you may have to incur for disinvesting and investing your money again. So somehow or the other, at the end, the conclusion of the story always remains that both of them will have same amount in their account by the end of 5th year, or at least theoretically they should have the same amount at the end of the 5th year. So this person accumulates from 0 to 5, and this person accumulates from 0 to 2 first, then 2 to 4, and then 4 to 5. These are the accumulation factors. Both of them should be same. This is the principle that you understand from this principle of consistency. This equation should hold true, and all our calculations of formulas or equations that we derive further will be considering this equation or keeping this equation in mind. So this is one of the example. Let me take another example. Let's say that I invest for 1 year. Mr. X invests for 1 year and seeks annual returns. Mr. Y invests for 1 year and seek monthly returns. Both of them are investing for the same time period, same amount, let's say, and Mr. X wants the bank to pay him return at the end of the year, and Mr. Y wants the bank to pay him return at the end of every month. So when the bank is paying interest at the end of every month, it happens that the interest amount that you earn in the second month will also earn interest on the interest that is credited in the first month. So let's say if you invest 100 rupees, it will become 101 rupee by the end of first month, and second month the interest will be 101 rupee, which will be 102 point something, and then in the third month the interest will be on 102 point something amount. So your interest on interest. So by the end of the year, you'll have, if interest rate is, let's say investment is rupees 100, you will get something more than 112. So even though 1% per month looks like 12% per annum, but it is actually not 12% per annum, because you're getting compound interest, you're getting interest on interest. So by the end of the year, you get something more than 112 rupees, and you can calculate and see that this should come out to be 112.6825 rupees. Now, since Mr. Y was promised by the bank rupees 1% per month, Mr. X, the deal that Mr. X should ideally sign with the bank is that Mr. X should get returns at 12.6825% directly, and not 12%, as 1% per month returns to Mr. Y will enable Mr. Y to earn 112.6825 rupees by the end of the year. So if Mr. X is also investing 100 rupees for 1 year, he should also have the same amount by the end of the year, and that is what principle of consistency states, that both of them should not have different returns based on their actions taken by them. So if this guy is earning 112 rupees, that means 12.6825% interest, Mr. X should also be given 12.6825% interest. So for a bank, paying 1% per month or 12.6825% per annum should be equivalent. 1% per month should never be equal to 12% per annum. 1% per month should be equivalent to paying 12.6825% per annum. And that is how it works, that is how it should ideally work. So this things really hold in practice. This is always true, and we'll be framing many concepts based on this. So you can take a note of this, and you can write the mathematical equation that we can say accumulation from any time 0 to time n. When I say time 0, it means the point where you're starting the investment, and time n is the point where disinvesting. This can be split into as many accumulation factors as you want. When I say T1, it does not necessarily mean time 1, it means the first time the money is disinvested. So here 2 is T1, 4 is T2, and 5 is T3. There have been 3 disinvestments, and this is the whole time period. So whenever you're solving anything, you can always keep a note of this equation and see if this is coming true. For any kind of calculation that you're doing in a question, if you realize that the principle of consistency is being violated, you are definitely doing something wrong. There is no question, there is no topic in all of the CM1 where this principle does not hold true. So make a note of this equation. This is the mathematical implication of principle of consistency, that you can split a0,5 in any kind of accumulation factor. Like here, this is a0,4 into a4,5, or you can also write this as a0,3 into 3,2. Everything should be true. This equation, or this equation, all of them should be equal to this equation. That is what principle of consistency tells you. Let us now move on to the next topic, which is very important. We have to understand the relationship between the discount rates and the interest rates. So let us understand that. Relation of I and D. Let us try to understand it in a very simple way. Let's say at time 0 I invest 100 rupees, and at time 1 I get 110 rupees back. One way of looking at this cash flow, I invest 100 rupees and I get 110 rupees back. So here I can say that the accumulated value of 100 rupees is equal to 110. Therefore, my I should be equal to 0.1. That means I have earned 10% interest on this transaction. And I can say 100 is the present value and 110 is the future value. Now look at this cash flow very carefully. If you increase 100 by 10%, you get 110. So I can say that 110 is 10% higher than 100. But by what percentage is 100 smaller than 110? by what percentage is 100 smaller than 110? So if the answer that comes to mind is 10%, it is wrong. 10% less than 110 means you have to reduce 11 from 110, which makes it 99. So 110 is only 10 rupees less. So 10 upon 110 should give you 0.09090909, which is 9.090909 cent. So to reach from time 0 to time 1, you have to increase 10%. But to come down from time 1 to time 0, you have to reduce only 9.090909%. So that's where the difference is. I can say that 100 into 1 plus I is 110. I can equivalently say that 110 into 1 minus D should be equal to 100. Look at the cash flow. This gives me D as 9.090909%. So there is a difference between the number of I and D. That is very clear from this transaction, from this example. Now let us look at the logic or a more practical aspect of having a different value for I and D. Let's say at time 0, I take a loan of 100 rupees. The interest being charged is, let's say, for example, rupees 10, payable at end of year. So at time 1, I have to repay 110. So I got 110 in pocket. I took a loan, so I got money in my pocket. I get 100 rupees in a pocket, and then I repay along with 10 rupees interest 110 rupees to the bank or whoever lends me the money. So repay at time 1 rupees 110, which means that my interest being charged is 10% per annum. I come to this conclusion very easily. This is one way of looking at it. Now let us look at it in a different way. The same thing. Let me come to the same thing in a different way. Let me assume that my loan was of rupees 110 now. In another case, I look at the loan of rupees 110. Let's say a bank says you pay me interest of rupees 10 at start of the year. Here it is at the end of the year, and here it is at the start of the year. So I have taken a loan of 110. If interest was supposed to be paid at the end of the year, I would have paid at time 1 110 plus the interest amount. But now the bank says that pay me the interest amount right now and repay the loan later. This is little bit impractical scenario, but that is how we are going to understand this. So let us assume that the interest was payable at the start. The bank takes the charges in advance, and you have to repay the money only by the end of the time period. So by paying rupees 10 at the start of the year, effectively at time 0, you have 110 rupees. You get 110 rupees from the bank as loan, and immediately you repay the interest, which makes the money in your hand equal to 100 rupees only. Don't remember the loan amount is 110. Don't forget it. But the 10 rupees charges are paid at the outset only. So what you will have left in hand at time 0 is just 100 rupees and not 110 rupees. Now at time 1, you have to repay how much? So loan amount was 110, so you should have paid 110 plus interest. Now since interest is already paid, so you repay only 110 rupees. Not the 100 rupees. Be very sure about it. 100 rupees is not the loan amount. The loan amount is 110. So ideally you should have paid 120 by the end of the year. But since that 10 rupees is already paid in advance, now we need to pay only the 110. The 10 rupees is already paid. So now here the cash flow looks like this. At time 0 you get 100 rupees in hand, and at time 1 you have to repay 110 rupees. Now the cash flows in both the cases are exactly the same. There is no difference. But here the interest was 10 rupees on the loan of 100, and here the interest is 10 rupees on the loan of 110. Here it was 10%, but here it is 9.090909%. So what is the catch in this? Now let's say the principle of consistency holds. If principle of consistency holds, both the investors should have paid the same return if the timing of the interest rate payment is same. So let's say for example, in this case, had the interest was supposed to be paid by the end of the year, the investor should have paid the same percentage. The difference, I should tell you, the difference is just because of the timing of the payment. Here the payment is at the end and here the payment is at the start. So they if you look at it, they are exactly the same thing, but we can interpret it in different ways. So one way of interpreting is the interest when payable at the end is always higher than the interest which is payable at the start. If you're paying interest early, you have to pay less interest. If you're paying interest late, you have to pay more interest. So here you're paying interest at the start, at the end, so you have to pay more interest. Here you're paying interest at the start, so you have to pay less interest. Now here, by the end of the year, you paid 10%. So here also, if the interest was supposed to be paid at the end, you should have paid 11 rupees and not 10. You paid 10 rupees only because the interest was payable at the start. So the bank basically gave you a discount of 1 rupee because the interest was supposed to be paid at the start. So you paid actually 10 rupees only, which is 9.09%. But had the interest been payable at the end, you should have paid here 110 plus the 10% of it, that is 11 rupees. Or similarly, in this case, if the interest was supposed to be payable at the start of the year, you should have paid 9.09% only and not the 10%. So the difference lies between the timing of the payment. If the interest is being paid at the start, the interest amount is less, and if the interest is being paid at the end, the interest amount is more. Now, if you can see, the interest percentages coincides with this percentages. So this amount or this percentage is generally referred to as the discount rate and not the interest rate, but it is actually the interest itself. So discount rate we can define in very simple term as interest payable at start of the year. If the interest is payable at the start of the year, we refer to it as a discount rate, and how much percentage should be paid should be consistent with this. So this is how it works in practice. We will derive a smaller, simple mathematical understanding formula for this. But for a very rough understanding, you can understand if interest is payable at the end, the interest percentages are higher and it is referred to as interest rate. If interest is payable at the start, the interest percentages are lower and it is referred to as discount rate. That's the only difference. Discount rate is also interest rate only. It's just that the cash flow is happening in advance at the start of the year, hence a different percentage is supposed to be paid. So this is the logical understanding. I hope it is clear to you. And if it is not clear, just let me know. This is a topic where sometimes people get little bit trouble in understanding, but if you have not understood it, let me know. I can convey it to you in a different way as well. So I'll leave it for you to understand right now for the time being. So make a note of these things and we'll move on to the next topic to derive the mathematical relationship between the interest rate and the discount rate. So we just saw an example of 100 and 110 rupees. At time 0 we had 100 rupees and at time 1 we had 110 rupees. So I can say that 100 into 1 plus I should be equal to 110. Also I can say that 110 into 1 minus D should be equal to 100. That means that 100 into 1 minus D raised to minus 1 should be equal to 110. Look at equation number 1 and equation number 2. This implies that 1 plus I should be equal to 1 minus D raised to minus 1 if these equations are true. And these equations are definitely true because 100 is the present value and 110 is the future value. So accumulation factor of interest rate and the accumulation factor of the discount rate can be equated with each other. They are equal. So this helps us derive simple mathematical formulas, smaller formulas, to convert from I to D or T to Y. In the previous example, we saw when interest rate was 10%, the discount rate was correspondingly 9.09%. That came through an example. Here also you can see the same thing. But if you want to derive discount rates for a corresponding interest rate in a faster way, this is how we are going to do it. So I can say I is equal to 1 minus D minus 1 minus 1, which is 1 upon 1 minus D minus 1, which is 1 minus D upon 1 minus D, which is D upon 1 minus D. Therefore, I can say that I is equal to D upon 1 minus D. Taking D as 9.090909%, you can cross check if corresponding I comes to be 10%, just to check if the previous example holds true with this relationship. Also, we can say that 1 plus I raised to minus 1 is written as, can be written as 1 minus d, taking this negative here, inverse function there. So d is equal to 1 minus 1 plus I raised to minus 1, which is 1 minus 1 upon 1 plus I minus 1 upon 1 plus I, taking the LCM. This gives me the answer that d is equal to I upon 1 plus I. So very simple formulas to convert from d to I and from I to d. So let us see, for example, if I is equal to 0.15, find d. And another example could be if b is equal to 0.2, find I. So take a calculator in your hand and simply write d is equal to I upon 1 plus I, which is 0.15 upon 1.15. Let's check what is the answer. 0.15 upon 1.15 gives you 0.13043478 as my answer. That is 13.04%. Keep in mind, that's very common sense thing, that d should always be less than I. Now, since we have defined d as the interest rate payable at the start of the year, if you are paying interest rate early, you have to pay interest rate lower. That is a simple funda. If you are paying early, you should pay lower because you get discounts. So interest rate, if it is 15%, that means 15. If you are supposed to pay 15% at the end of the year, and if you can pay 13.04% at the start, both are one and the same thing. The bank should not have any problem with this. And if discount rate is 20%, the interest rate should be a bit higher. So I is equal to d upon 1 minus d, which is 0.2 upon 0.8, which gives you 0.25. So you can pay 20% interest at the start of the year, or you can pay 25% interest at the end of the year. They are both one and the same thing. The bank should not have any issue with it. So for you to understand, deciding, like, the question might be coming in your mind, that whether the person should pay interest in advance or whether the person should pay interest at the end. Interest in advance is always lower than the interest at the end. So you could well satisfy your bank by paying 20% at the start, or you can satisfy yourself by paying 25% at the end. Whatever is convenient. Just a very basic understanding could be like this, that suppose if you have money and you have a way to invest it. By investing your money, suppose if you can earn 30-40% returns on it, just hypothetical figure, if you're able to 30-40% returns on it, and here you're getting just 20% discount, then it is better to invest your money somewhere else and pay the bank interest later. So suppose if a loan is of 100 rupees, then the interest payable at the start is say 20 rupees, and interest payable at the end is 25 rupees. So instead of paying 20 rupees, instead of paying 20 rupees at the start, you can invest the 20 rupees somewhere else. If that can earn 30% returns, that will become 26 rupees, and here you'll have to pay only 25 rupees. So you'll make a profit of 1 rupee by not paying in the installment or the interest payment to the bank in advance. And if you have got no ways to invest it, if suppose your money will be lying idle, then better pay early so that you at least get this 20% of discount on the early payment of the interest. So only if you know that your money is worth more than this discount, 25% to 20% is discount of 20%. So if your money is worth more than this discount, you can put your money wherever you feel it is better. And if you think that your money cannot earn more money itself by lying with you, just better give it to the bank, repay your interest early, so that at least you get the discounts on payment of your interest rates. That is how it should really work in practice.